day, my fellow chemical engineering students, and at this point, I'd like to assume that a lot of us have already seen a chemical processing plant, yes? Or better yet, have the experience to be inside one. Am I correct? Yes, how lovely is that? But think about it. Without chemical processing plants, how do you think the world is going to look like nowadays? I'd say probably a lot simpler and a lot safer, but who knows? All we know is that mishandled chemicals in a chemical plant have the highest chances of catching huge fires, explosions, oil and gas leakage. Now, have you noticed the recent situation in Mexico where the sea was on fire? Also, if you could remember, the warehouse explosion in Lebanon last year, which was caused by ammonium nitrate. Have you heard of that? Maybe yes, maybe no. All I know right now is a question in your minds: why am I talking about this? Yes, that's a good question, because just in time, we, the Damla Group, will present to you a case study analysis about safety management in chemical processing plants. And yes, we all hope that you find our analysis informative yet a very entertaining one.
As we all know, safety is one of the main components of having a good working environment. Securing the workers' safety is a must to build a good company. In the chemical engineering profession, this is a valuable factor because harmful and dangerous situations may highly occur in the working place. For this reason, the problems should be identified and we should look for a solution to prevent these problems. Or if these problems occur, it will be easier to solve them. One of the underlying problems in the workplace is the workers' chemical exposure during processing, producing, using, handling, packaging, and shipping. This problem may pose many problems in the long run if not handled properly. It was concluded that to prevent this problem, workers are given proper training in handling the chemicals and having them use the PPE if they are in the field.
Problem statement. Problem number 1. The increasing use of chemicals, either man-made and natural, can cause serious damage to the health of the workers. It has been estimated that approximately 1,000 new chemicals come onto the market every year, and about 100,000 chemical substances are used on a global scale. These chemicals are usually found as mixtures in commercial products. 1 to 2 million such products or trade names exist in most industrialized countries. Problem number 2. Leaks and spillage can still occur despite the continuous flow methods. More substances and rising production mean more storage, transport, handling, use, and disposal of chemicals. Hazardous substances can leak, cause a fire, or give off dangerous fumes and vapors. When two substances come into contact with one another, they may react violently. The reaction products may be more dangerous than the original chemicals. Problem number 3. Maintaining and cleaning the equipment can be dangerous because it still exposes workers to chemical hazards. Most chemical accidents have a limited effect. Occasionally, there is a disaster like the one in Bhopal, India in 1984, with thousands of deaths and many people permanently disabled. No chemical substance can cause adverse effects without first entering the body or coming to contact with it. There are 4 main ways, that is, routes of exposure for chemical substances to enter the human body. These are the following: inhalation, absorption, ingestion, and transfer across the placenta of a pregnant woman to the unborn baby. According to the International Labour Organization, or ILO, the harmful effects of chemical substances depend on the toxicity and the exposure to that chemical. Toxicity is a property of the chemical substance, while the exposure depends on the way the chemical is used. The level of exposure depends on the concentration of the hazardous chemical and on the period of contact time. Many substances do not give any warning by odor, even though they may be present at dangerous concentrations in the air's workplace. The second part includes the symptom of underlying problems. The worker's exposure to chemicals during processing, producing, using, handling, packaging, and shipping is our symptom of underlying problems. All 3 main problems are issues that need immediate assessment. However, the third problem requires most urgency because equipment maintenance is one of the tasks that most employers work on within a plant. Chemical use and leakage occur if there's poor maintenance and poor quality control during production, handling, packaging, and transportation. All issues are crucial as all of them puts the worker's safety in the line. And the third part is differentiating between importance and urgency. Our problem number 1, which is the increasing use of chemicals, is deemed important. The problem number 2, which talks about leaks and spillage that can still occur despite continuous flow methods, is also important. However, the problem number 3, which is maintaining and cleaning the equipment, can be dangerous because it still exposes workers to chemical hazards, is urgent. Without proper maintenance and cleaning, the company's increasing use of chemicals might be compromised, which may also result in leaks and spillage. The third problem, therefore, has a more significant effect on the efficiency of the plant production, which affects profitability, source of competitive disadvantage, and the morale of employees. If these were not addressed immediately, it may affect the overall strategic direction of the company and customer satisfaction. So what should the chemical plant do to resolve these safety issues?
Now, chemical industry problems are very dangerous, and most of them stem from resources, people, and unsafe processes that are involved in each production. Everyone is affected by these issues, especially the people working inside the plant. The National Fire Protection Association, or the NFPA, has come up with various classifications that highlight the common hazards in the industry. These are flammability, reactivity, and toxicity. The NFPA also included a PPE classification. All these classifications hold different constraints and opportunities that may affect the plant. That's why we have developed a list of alternatives below to determine which must be prioritized first. For the alternative 1, we have here established the code of fire hazard degrees according to the susceptibility of materials to burning. Alternative 2 is to establish the code of degrees according to probable severity of hazard to personnel. Alternative 3 is establish the code of reactivity hazard degrees according to the susceptibility of materials to release energy. And lastly, for alternative 4 is to evaluate and implement various PPE codes recommended for handling the different types of chemicals. After identifying all the alternatives, we have evaluated and determined which among the alternatives and classification is the most crucial in maintaining the plant safety and optimum production. For alternative 1, this option is obtained from the Material Safety Data Sheet, or the MSDS, and the National Fire Protection Association NFPA coding criteria. This is one of the basic and the main concerns when it comes to hazards in chemical industries is to ensure the fire safety. It is essential to adjust process safety, workplace safety, and preventive fire protection in every chemical industry to avoid creating a nearly infinite variety of hazardous conditions and to minimize the risk and to reduce the severity of fire incidents for the safety of the workers. Alternative 2, this is similar to Alternative 1, in which this option is also obtained from the Material Safety Data Sheet and the National Fire Protection Association NFPA coding criteria. Now, working with chemicals can potentially harm both the health of the workers either temporarily or permanently. Hence, identifying the hazard beforehand, assessing and controlling the risk can reduce their chances of getting injured or disabled. For Alternative 3, this alternative is similar to Alternatives 1 and 2. This option is also obtained from the Material Safety Data Sheet and the National Fire Protection Association coding criteria. This is the most crucial alternative that must be thoroughly understood and controlled, as this will seriously and catastrophically present danger to the workers. Inadequate recognition and evaluation of reactive chemicals may result in hazardous chemical releases that casually lead to fires, explosions, toxic or high-energy events. Hence, it is vitally important that this chemical reactivity hazard be anticipated, recognized, and conducted safely in every chemical industry to ensure the health and the safety of the workers. Lastly, for Alternative 4, this option is obtained from the Material Safety Data Sheet coding criteria. Among all the other alternatives, this alternative gives the workers extra protection in an event of an accident against any hazardous conditions. Since working with chemicals can cause serious injuries and illnesses, personal protective equipment is categorized as eye and face, hand, body, respiratory, and hearing protection. The purpose of protective equipment is to minimize the worker's exposure to health and safety risk effectively to an acceptable level when all the other alternatives were not feasible or when no other safety measures are available. This thus works best when the workers uses it to supplement higher level control measures or along with the other alternatives and some high risk assessments. Now, after thoroughly evaluating all the alternatives, we have come up with several decision criteria that will determine which alternative is the best for the issue. And these are: the first, we have relevance in the material safety data sheet and the National Fire Protection Association coding criterion, which is the most important criterion to instigate effective prevention of hazards for safe chemical handling. Next would be maintains employee morale and safety, improve or at least maintain profitability, increase sales, market share, or return on investment in the plant, maintains consistency with the corporate mission, feasible within the plant's present and future resources and capabilities, and easy and quick to implement. Now, for the final decision, the most ideal alternative that fits all the decision criteria laid out in the previous section is alternative 4. Without proper PPEs, workers will not be able to follow all the other alternatives despite knowing all the crucial NFPA coding criteria. Alternative 4 is also the most efficient option in maintaining employees' morale and safety. A good workplace likely yields excellent production, which in turn results in improved or maintained profitability. This will then result in increased sales, market share, and return on investment. Implementing proper PPEs will also result in corporate consistency while maintaining feasibility. Lastly, considering feasibility can result in an easy and quick implementation.
Handling, packaging, and shipping can cause serious damage to both workers and the surroundings. To address the issue and to ensure that accidents will be reduced or better be eliminated, an active accident prevention program was made, and one of these is safety management. This case study focused on safety management that was conducted at a chemical processing plant producing ink. Classification of raw material was based on Material Safety Data Sheet, or MSDS, according to National Fire Protection Association, or NFPA. Safety in the workplace is a very important issue in the status quo. As the phrase by Benjamin Franklin, by failing to prepare, you are preparing to fail. Preparation is the key to mitigate accidents and uphold a safe manufacturing environment in a chemical processing plant or any other establishments or manufacturing. Choosing the ideal alternative comes with challenges as all of them fits more than one criteria. And upon considering all alternatives and evaluating these alternatives based on a decision criteria, we have come up with the best decision to pursue first, which is the fourth alternative. It fits all decision criteria first and is the most feasible among all alternatives. Alternative 4 is also the best choice that upholds workers' safety and produces excellent general outcome for the betterment of plant production. Therefore, it must be prioritized.
Recommendation: it is very important to ensure safety in the workplace since it is an issue in today's manufacturing environment. To avoid such accidents, the employees must be informed about the hazard of various chemicals so that they are fully aware and take proper precautions. In addition, they must also be aware of the NFPA 704 standard systems for the identification of the fire hazards of materials, which helps them handling and storing hazardous materials, as well as those responsible for emergency service by providing a rapid visual indication of hazards by the NFPA system. Employees must not also forget to wear personal protective equipment or PPE at all times, especially when dealing with hazardous materials. Lastly, all the employees or workers must be first given comprehensive training and are well trained about the use of the coding system, as well as the importance of using the right PPEs and other relevant aspects of the system. The following are the reference list of our case study. And that's it. That would be all, and thank you for listening.